What's going on, YouTube? Mud Duck Sharky here. I am starting a new project and I am stoked about it. Well, I'm not really starting it. I've been working on it for a long time. So I've had this crazy idea in my head that I'm going to go and build a 4-pill LDMOS. And I'm going to overkill it. I'm gonna super duper overkill it. It's going to be continuous duty. Try finding an 11 meter amp that's continuous duty. Try. I'm sure they're out there, but just ask around. Ask your builder. Ask your builder for a continuous duty amplifier at any power level that you can crank it to. Carrier, full CW, AM, FM. Ask your builder if your amplifier is continuous duty. It ain't. So overcoming that was a nightmare. It mostly has to do with cooling and making sure that your devices are cool. These little MRF devices. So that was my biggest hurdle. I spent a long time working to make that happen, theoretically, and then I tested it on the bench, and then I tested it some more, and then I tested it some more, and so far so good. So I got that down. It's going to be a 4-pill LDMOS. And like I said, I'm going to overkill it. So I got the power supplies. They are overkill. They will run the amplifier continuous duty, full output, FM, AM, as much as you can get out of them. You know, they'll do it. And right now I don't have a whole lot of the parts together. So this is just part one. I'm just going to do a little bit at a time. This might be a 2-part series. It might be a 5-part series. It might be a 10-part series. I don't know. I got a lot of stuff going on. I got the chassis for it's being manufactured right now. So hopefully that's done over Christmas vacation for me, and I'll have a chance to put it together, or at least get most of it done. I've got all the designs done, got PCBs printed, I've got it all drawn up and 3D modeled. I've got my water cooling components on order, and I've got just about everything else I need. So today, just part one, I'm gonna figure out how to solder these LDMOS devices to the heat spreader. So I don't really have heat spreaders. I have water blocks. It's a little different. Let me flip this camera around and I'll show you what I'm talking about. Alright, here's my project for this evening. I'm gonna figure out my soldering parameters to get these suckers soldered onto these water blocks. So this is solid copper. And this is the side that the chip gets soldered to. So you notice I made these channels in these holes in the corner. What these are for is these are for overflow of the solder. Let me bring my light in here so we can get a better look. So what these holes are for in these slots, these are for solder overflow. Just in case I put a little too much solder paste on there, or you know, whatever, it'll overflow into the channels instead of pooling up around the base of these devices. So this side's pretty simple. Just got some mounting holes, some relief cuts so that it doesn't interfere with the through-hole components on the circuit board. Here's the fun side. So these are all made by CNC machining. These channels are cut for the water to flow through. So water comes in one side, flows through all these channels, flows out the other side. And this is a 2-part item. So it's got a cap that goes on the other side. You notice there's this groove right here. There's an O-ring that goes in that groove and seals the cap on top. So these threads are BSPP threads. So they're kind of like an American pipe thread, but they're slightly different, and they're a straight thread, not a tapered thread. These are an O-ring seal. I don't have the fittings on the bench. Maybe I'll grab them in a minute. I'm using PC water cooling fittings. They pretty much all the PC stuff uses the same threaded fitting. They're barbed fittings, but with a locking ring. Really slick fittings. Really smart, large diameter fittings that allow lots of flow. Really easy to disassemble. Just generally good stuff. So I've got a bunch of these. I got to solder the LDMOS to them, but I got to figure out how much of this here solder paste I need to put on there. So that's my mission for today, and maybe I'll solder up these blocks as well. I'll do at least one of them on camera if I get to it this evening. But I've got this old heat spreader. This one is one that I won't be using anymore, so it's going to be my test dummy. Right now it's got some residue on there. That is not solder. That is liquid metal. So I might as well throw that into the video. This is called Grizzly Conductance. This is a gallium, I think it's a gallon stand alloy. So it's a little syringe inside this package, and it's actually liquefied metal. And it flows kind of like mercury, but it doesn't have any mercury in it. You know, it's got a really low melting point. If you're interested to know more about this, just look up CPU computer guys. This is a product for high performance computers. What the guys do is they take the heat spreader off of their CPU, and they put a little bit of this in between the die of the CPU and the heat spreader to improve the temperatures of the CPU for better performance and overclocking. But it's also great for testing. This stuff is amazing for testing LDMOS chips. It's actually more thermally conductive than solder. With that said, it's only good for testing. It might be good for about a year or two, so I'm told. And then you have to change it out, and you have to replace it. So, I've never seen this stuff go bad, but I've heard that it does. I've heard that over time it goes bad. So if you choose to use this in your amplifier, be aware of that. And there are also some special application procedures for using this. It's not like standard heatsink compound. You don't just put a little drop on there, put your device on, call it a day. You have to Scotch-Brite your surfaces, clean and shiny, clean them with ethanol. And you have to apply it to both the chip and the heat spreader with Q-tip. And you have to spread it around until it flows like liquid across the surface. And you have to make sure it covers the entire surface, and that the liquid metal is chemically adhering to the surfaces that you're applying it to. Otherwise it doesn't work, and it's all bad, and you're going to have a bad time. So there's PC guys, they'll show you how to do that. There's a million tutorials out there. Just look up delitting your CPU or CPU liquid metal. You'll find videos. But anywho, I figured I'd throw that out there because I love this stuff and it works great for testing. Because I'm taking chips on and off of there, and it's as good as solder, if not better. According to the data sheet, it's better, but you know, who wrote the data sheet? Am I right? Anywho, so I am going to take this, I'm going to clean it up, and I'm going to figure out a tripod situation, and I'm going to solder this, solder one of, I'm not going to solder a good one. I'll solder one of the old ones, one of the blown ones. I'll solder it up on there, and we'll see how much of this this paste we need, and yeah, then we'll do a good one. Let me change out cameras and get ready. All right, so I'm over to a different camera now. Hopefully the audio and the video is okay. Ready to do this. So I'm just going to solder the part to the bottom side of the spreader. It's basically scrap copper, so it doesn't really matter where I solder it. I just want to check it out. I've already hit the copper with a piece of Scotch-Brite. Got it nice and clean. Got an old burned up chip here. Get some of this goopy, nasty stuff off of it. This heatsink compound, that's back before I knew anything about liquid metal. Had I known, I would have been testing with the good stuff. Probably still would have blown these chips up though, because my heat sinks were just getting too hot. That time has passed, and I've learned a few lessons about that. Any of you that might go down the road of messing with these LDMOS devices, first thing you need to take into consideration, well, if you know how to build an amp, that is, you know, Toshibas and stuff like that, bipolars, they're a little more tolerant to being overheated, but these things, they don't like it. Consider junction temperature. The junction temperature of the transistor inside of there. Take a look into that. It's pretty critical. Yeah, good enough. Alright, let's see what this solder paste can do. Some goopy stuff. I think that's sufficient. That's probably a lot more than I need, but that's why I'm doing this. I'm figuring out exactly how much of this goop I really need. That's definitely too much. This is actually my first time working with solder paste in general. I've used a lot of different forms of solder. TIG welded it, I've torch welded it, I've welded it with an iron, I've done lead, I've done tin, done silver, done antimony compounds. Worked with a lot of solder-like metals, but for some reason I've never had to do paste. I think that's the magic amount. Let's see what happens. Alright, I'm doing it the old-fashioned way. Propane torch. Because MAP gas just ain't what it used to be, you know what I mean? It's probably going to take a minute. So I'm going to get cozy. You guys can see that, but solder looks like it's flowing in there. It's not melted yet, but the flux is liquefying. So when I do these on the final device, I'm gonna find a piece of something, like a piece of metal. I'm gonna set that on the chip so that it minimizes the gap between the device and the spreader. Because the smaller that gap, the better off you are. Believe me, 1/1000th of an inch is a mile, and it makes a huge difference in temperature, especially if you're not soldering. 1/1000th of an inch worth of heatsink compound can make a several degree difference. And with these LDMOS devices, you need every degree you can get. Every little bit of thermal performance you can get, you gotta get it. So, first impression, that's a whole lot of solder. Might be too much, but let's see what happens when it melts and we clean it up. So this solder paste is 6337. It's about the lowest melting point I could find. It's the stuff I use on my bench normally. Looks like we're almost there. Wonder if maybe I should heat up the spreader first and then put the chip on it. Thinking that might be a smart idea. Maybe just spread a little bit of paste on there first, get it going, and then once the spreader is nice and hot, or the water block is nice and hot, maybe then I can put the chip on. Still not melting. Need a more badass torch. Oh, magic is happening. Oh, the magic just happened. I love that. Okay. Oh, look at that. Flux did its job. Solder flowed real nice. I think I used too much though. It's kind of puddling up around the edges. Probably be okay, but I'm not going to use that much if I don't need to. Let's take a look underneath. Oh yeah. That's pretty good. And it's stuck. Okay, so for the next run I think I'm going to heat it up until this stuff really is about to melt, and then I'll throw the chip on there. Let it equalize temperature wise. Yeah, that looks really good. And then I'll throw a weight of some kind on top of it to make sure that there's very little gap. Like I said, that makes a big difference. Maybe I should grab a wet rag so I can cool these down faster. Alright, well that was fun. I think I learned everything I need to know. I'm going to give one of these a shot. Let's do it. Okay, I think I'm ready to go for it. So before I go soldering these on there, I'm going to attempt, I'm not going to attempt, I'm going to actually do it. I'm going to measure the turn-on voltage for these and see if it changes after we solder it. Just out of curiosity, I want to see if the heat has any effect on that. So I watched another gentleman's video. I don't remember what his channel was or what his call sign was, but he walked through this process and he did it a little differently. He did it with a hot plate. Hopefully that's in focus right there. Alright, 2.78 volts. Let's see what we get over here. Yeah, right about the same, 2.79, give or take a few millivolts. Okay, yada yada. There's a lot of data in here I never really paid attention to. Anywho, let's give this a shot here. Okay, so last time I think I kind of overdid it with the solder paste. I was saying I was watching another video of another gentleman that did a process like this, and he did it on a hot plate, and after he was done soldering he just took it and set it on a heat sink to let it cool, and I thought that was a good idea. So I am going to go with that. That makes good sense. Alright, got our chip. Got our goop. Plenty of goop going on here. What do you do if there's not enough goop? Unsolder it and try it again? I guess you got no other option in that case, huh? Hopefully it doesn't come to that. But we shall see. I think we'll be okay. Really don't want that on the tabs right now. Not yet. Not time to solder that. Oh, no. Get off of there. Okay, I'm officially making a mess here. It'll be okay. Alright, I'm satisfied with that. Hopefully that does the trick. Hopefully I solder this to the spreader in the correct orientation. That would be good. Okay, let me bring this over this way. Check and make sure this is in focus so you guys can enjoy it. There we go. Hopefully that's in focus. And I decided not to put the device on after heating the block, because this is actually, there's not a whole lot of copper here. Most of the copper's been removed, and it's actually pretty lightweight. So I think it's going to heat up quickly. And I think this whole process is going to be over with pretty quick. Okay. Here goes nothing. Forgetting something, aren't I? Yes, I am. Like I said, I'm just putting that there to make sure that the gap in between the device and the copper is as small as possible. If I had something heavier than that, I would use it, but that's the first thing I grabbed. Come on, baby. Oh, she's bubbling. She's a bubbling. There's that magic moment where it all goes shiny. That's pretty cool. There it is. There it is, boys. First tree. Okay. Alright, I'm going to let that solidify, take the weight off, set it on the heatsink, and we'll test it and see if the gain, the gate source turn-on voltage changed at all. That's what I'm curious about. Alright, that's solidified. I'm gonna go clean up my mess here, and we'll be back and we'll check that out in just a few minutes. Is this in focus? Oh yeah, that's in focus. So our VGS dropped by a tiny 20 or 30 millivolts, maybe 40 millivolts. I don't remember what these parameters were. We only saw them on the other gate. I'll have to go back through the video and see what they were before soldering. But yeah, I mean, it all looks very reasonable. Nothing went haywire as far as I can tell. Trying to make sure this is visible on camera while I'm doing it. I'm a total noob. Okay. Yeah, the VGS dropped just a tiny bit. Just a tiny bit. Which is interesting. I've heard if you resolder these things over and over again, they just don't work like they used to, so I'm trying to avoid having to resolder them. I haven't cleaned the flux off of this yet, but that's coming. Focus. I changed color a little bit there. Lost a little bit of its clean. That's just copper though. Always patinas. Alright, I'm gonna go clean the flux off of this and see how she looks. Back to the cell phone we go. Alright, so I got the sucker cleaned up. And she's looking pretty snazzy. I'm happy with it. I feel like that was a success. I feel like that went really well. So much more work ahead. I gotta do a bunch more of these. I gotta put all these together. Then I gotta move on to the water cooling stuff. So this is one of 4 radiators for the 4-pill unit. So each transistor is going to get its own radiator just like this. And if you're looking at me thinking, hey, that's a little overkill, dude. Yeah, it is. Continuous duty, baby. This is what it takes. I'm not kidding. So these are the fittings. These things are pretty cool. See, I don't know if I'm going to be able to do this one-handed. Here, let's see. Let's see if I can do this. So here is the cover block that goes on here. And these fittings have an O-ring seal. So basically, you just thread these on here. There we go. Do that one-handed. Okay, so here's the barb. And there the barb went. Here's the barb for these fittings. Focus. And it's pretty nice fittings, man. These things are really cool. So it's a really short barb. So the fitting itself is really short. You can work it into tight spaces, especially for, great for computer stuff. What you do is you install this just like that. And then it's got a hex inside so that you can tighten it down. And then you take your tubing. This is metric tubing, by the way. Metric fittings. Because metric is where it's at, baby. Okay, and then once you get your tube slid on there, you take one of these rings and you screw it down tight. So that's one of the great things about these fittings is they're really easy maintenance and they hold very securely. So they do really well with 30 psi or so. I probably wouldn't push it much farther than that, but yeah, it's really cool. These rings, they actually pinch the hose down onto the barb, and they're only about $2 or $3 a piece. Pretty cheap as far as pipe fittings go. You go to Home Depot, you're going to spend $5 a fitting and get a much more inferior product. But yeah, hope this was a cool little intro, and there's plenty more to come. I'm going to try and get a bunch of it on video. I'm going to put some of these boards together, all the transformers, soldering all the components together, all that good stuff. That's how that goes on there like that. And then you screw it down, solder it down, put all your parts on, all that fun stuff. Anyway, it's time for me to call it a night. I'm going to come back in the morning, solder the rest of these. But it's been fun. Hope you enjoyed the video. And I will be back with many more. Mud Dug Sharky, and I'm back out for now.